we describe the process and initial outcomes of a design exploration focused on creating an embodied conversational assistant specifically for a learning space. This project was created by an interdisciplinary team of faculty members, an intern, and a former student. Learning spaces are designed to support and enable learning processes. What interactive elements can be added to a space to support these goals? Our learning center, the Kadar Design and Technology Center, is focused on interaction design and hands-on prototyping, bringing together students from design, engineering, and art. It is a test bed for exploring these questions. We start with a bit of background. Conversational assistants and social robots are increasingly being used in the context of education. They are assuming different roles in learning interactions. While often the agent is set up as a tutor or teacher, some systems have given the agent the role of a peer or novice. Robots have a history of task and location specificity. For example, industrial robots are designed for painting cars, service robots for dispensing items to hotel guests, and social robots for keeping company for elderly people in assisted living. Conversational assistants, on the other hand, tend to be generic, accessible in different locations, and even through different devices. In the middle, between robots and CAs, is an area of physically embodied agents with whom the interaction is based predominantly on conversation. Creating such an entity requires presenting character in a coherent way through form and behavior. We were interested in exploring this area for our learning space. To begin the process, we engaged in discussions with our stakeholders, faculty, collaborators, interns, and most importantly, students, to understand their experience of the center. Our main insights were: it is challenging for newer students to know what equipment they need and where to find it. Much of the center's knowledge, such as past projects, is concentrated in the staff. Some students hesitate to ask questions for fear of appearing unknowledgeable. And recurring basic technical skills like soldering can be practiced with simple guidance. From these insights came the vision of a social, conversational entity that would reside in the center's space and would augment the existing staff with specific abilities. Our conversational assistant would be knowledgeable, it should be familiar with every project, and should know where every piece of equipment is stored. Spatially persistent, it has to be accessed in different locations around the space to help with different tasks. Vulnerable. While knowledgeable, it needs to be vulnerable so that students feel comfortable with it. Vulnerability has been shown to increase engagement and trust in human-robot teams. And respectful of privacy. Some students would feel comfortable with the conversational agent only if they can interact with it without feeling documented. At this point, we felt the need to name our assistant. Searching for a name that was neither male nor female, we took the first letter of our center name and named our assistant with it, K. We synthesized our discussions with stakeholders into storyboards and video scenarios, exploring different aspects of K's role and behavior. Scenarios dealt with welcoming new students, guiding students to equipment, and chaperoning an introductory soldering session. Two of the storyboard scenarios are presented. In one, K welcomes a guest and shows videos of projects using a nearby screen. In this next one, K introduces a soldering table using an overhead projector. Given K's attributes, we knew it had to be physically embodied and not in a generic form. Defining a new form would allow us to make K truly specific to the space, as well as enabling new hardware for specific functionality. It would provide an opportunity to give K character through its form and the links between form and behavior. We needed to decide whether there would be a single unitary K or more than one. Studies have shown that in situations that require expertise, agents that move between different bodies raise concerns for users. We therefore prioritize an individual and unitary K over the potential utility of having several ones. Our single instance of K would need to move around the space. Following our scenarios, we decided that the users of K would move it between a set of docks that would be located in strategic areas in the space. K would ask to be moved to a certain dock, from which it would guide and explain the specifics for that location. We hypothesized that designing such mutual dependence between the human and conversational agent would contribute to its vulnerability and to mutual affinity. In this decision, we were inspired by Hitchbot, the hitchhiking robot, whose need for help garnered huge sympathy from the involved public. The requirements for K were emerging from the scenarios and discussions. K would be based on conversation only, without a camera. Communicate attention and engagement to encourage interaction. Be able to point so it could help in locating things in the space. Be easily carried but substantial in its presence, and be able to dock in distributed locations around the space.
In this phase, our goal was to represent in shape, color, material, movement this new entity. We began with brainstorming sessions about different characters from movies and stories. We listed their main characteristics and selected the most important ones for K. It would be smart, helpful, and dependable, but also sometimes needy. Since K's functionality does not dictate a specific form, we needed design metaphors. We chose the owl that we imagined sitting on a branch and sharing its knowledge. We also referred to K's technical origins. It belongs to an ancestry of social robots. Our initial sketches represent these qualities: a general configuration, a way to communicate the conversational nature of K, and physical handles for its locomotion. We designed the speaker as a rotating head. This movement will enable K to express emotion, communicate attention, as well as orient towards certain location. The current K model balances between owlness and robotness. It is 3D printed in-house to give it a local origin. K's perch, a dock mounted on the wall, is designed to fit the center's interior design.
We defined the three goals for K's textiles. The textile's most dominant role was to cover the exposed area where the head movement originates. This divided the body into exposed and hidden parts and marked the bottom part as a holding area. In addition, a textile solution should support K's movement and also emphasize them. Lastly, a textile component brings a tactile quality to any product and invites touch. Therefore, it is a good starting point for emotional bonding. We started the process with a variety of fashion drawings, but realized that cut and sew was not the right approach in this case, since it is too meticulous at this scale and it creates a more feminine look, which we wanted to avoid. We then selected knitting as our fabrication method, since it can offer a variety of flexibilities in one garment, creating a more homogeneous look. The color and knitting patterns are intended to emphasize K's movement.
For implementing the conversation, we created an Alexa skill using voice flow, which is run on an Amazon Echo Dot device embedded inside K. The Dot device is hacked for using an external speaker and microphone, as well as being operated by a rechargeable battery. In order to run the videos in the welcome scenario, the Dot sends an API request to a computer connected to a screen. A servomotor span and tilt mechanism is responsible for head movements of K. This mechanism is run by an Adafruit ESP32 board, also fed by API commands sent from the Dot.
The first implementation of K is focused on our welcoming scenario, a student arriving at the center for the first time. The scenario includes a short conversation in which K introduces itself and asks the student for their first name and study program. It then proposes to watch a short movie together, selecting a project relevant to that program. If the user agrees, K asks to be moved to the screen perch. When placed there, K describes the project and then the movie begins on the screen. 8 students experienced the welcome scenario individually at their first visit to the center. They were then interviewed and filled out a questionnaire. The general experience with K was of surprise and enjoyment. Students appreciated the potential of this new form of assistance and were enthusiastic about additional possibilities that they suggested. The text-to-speech engine did not work well enough with some students' non-native English names and accents. While some were amused, a few felt uncomfortable with this. To reflect. Envisioning K as an idiosyncratic expert in a very specific learning space has been a rich ground for new interaction ideas. The spatial distribution of functions in our space led to the idea of locomotion. The dependence on users for locomotion led to the thought about vulnerability. Having a single K inspired us to the idea of docks around the room, and the docks enabled us to add functionality to K using existing devices. We view this process of creating and crafting K for a specific space as a promising process within interaction design that we hope to see continued and advanced. We're especially curious to see what conversational assistants will be born in other interaction design labs. Thank you very much.